Hey guys, remember when we were talking about observational studies and we needed to get information to draw conclusions about a population? There are two ways that we did it. We did a simple random sample and a stratified random sample. A simple random sample in In experiments, if we can get things a couple different ways, we can get data a couple different ways in an experiment. We can do a completely randomized design, which is kind of like a simple random sample in an observational study. Or we can do a block design, which is kind of like a stratified random sample in an observational study. I think you can maybe hear my kids upstairs, so I completely apologize if you can hear any background noise. Okay, hopefully I'm talking loud enough so you can't hear them. Okay, so a research company wondered if women and men respond differently to advertising. An experiment to compare the effectiveness of 3 television commercials for the same product want to look separately at the reactions of men and women to assess their overall response to ads. Let me just quick recap what a completely randomized design looks like for you guys. Okay, in a completely randomized design, if let's say that out of this women and men, there was 100 people total, okay? We're gonna just play pretend. We don't know, but we're gonna just say that, okay? In a completely randomized design, what I would do is I would have all 100 people start right here. I know that there are 3 television commercials right here. So that means that I would need 3 treatment groups. 1, 2, and 3. I'd break them up roughly by a third, okay? So it doesn't have to be perfect. Group 1 would have n equals, let's say, 33 people. Group 2 would have n is equal to 33 people. Oopsie. And then finally, Group 3 would be n is equal to, what would that be? 60 or 34 people. Okay. Together, that's 100 people. So this is a completely randomized design, what I did a video on previous to this, okay? Next, they would have to have their treatment groups. So treatment 1, treatment 2, and treatment 3. And again, these are all different commercials. So it doesn't describe what kind of commercials they are. So I'm just gonna put treatment 1 would be like commercial 1. Treatment 2, oopsie, forgive me here. And then finally, treatment 3. Okay, and then finally, we'd want to look at the responses. And with this here, we would say, well, which commercial did score the best with how people responded to those ads, right? The issue is what if in one of these groups there was a bunch of women or a bunch of men, okay? We could say this one was disproportionately had more men in it or more women in it, whatever, it doesn't matter. You could just envision, okay? Well, then we don't know all of a sudden if we think, okay, and we're not saying that this is true, but if we think that they might respond differently, we don't know was the responses because this commercial was really the best, or was it because of the lurking variable that there was more of one gender in that group, okay? So what we do then is we do a block design. And we break up the men and the women before, okay? So I would say, hey, I have 50 men and I have 50 women. I'm going to break them up into different blocks. And now what I'm going to do is I'm going to do this experiment for the men and for the women. Now what I'm doing is I'm controlling that lurking variable, okay? So again, I would do 3 groups for the men, again, randomly getting there. So group 1, we would say, let's say they had 18. Group 2, we would have 18. So what is that together? That's 36. And then group 3, we would have 14 people. And they don't have to be equal. We like them to be as equal as possible, but they don't have to be. Obviously, with the 50 divided by 3, we can't do that, right? Okay, next, and I just chose that off the top of my head. I could have done, 15, 15, 20, whatever. It doesn't matter, okay? Now, next then I would say, okay, well, we have the 3 different commercials. Once they're in the group by random, remember, it is by random assignment. So I'm going to put RA here for random assignment and RA here for random assignment. Okay, now they're in their groups, right? Now we have treatment 1. we have treatment 2, and we have treatment 3. Okay, and then, right, we're going to compare the results. Excuse me, we're not going to compare the response. We're going to look at their response to the ad. And we're going to do the same thing now for the women, okay? The same thing for the women. So again, I would break them up into their 3 groups. Group 1, oh, I don't like doing that because I'm not as good there. Group 1 would equal 18 women. Group 2 would equal 18 women. And like I said, I just made up these numbers. We want to, somewhat equal. You could have done 17, whatever, okay? But again, somewhat equal. Usually in the problem, they make it so it's easy to split. Group 3 then would be 14 people, okay? Again, then we would have them each go through a treatment group, or they would get their treatment, excuse me. Treatment 1, treatment 2, which would be commercial 2, and then treatment 3, okay, which would be commercial 3. We're going to look at the women's responses, and then let's just play pretend, okay? Let's say treatment 1, that commercial really did score the best for both groups. Now we know that it scored the best because it was really truly the best commercial, and not because there's one more gender in a certain group than another, okay? It's a way to control a lurking variable. Let's say treatment 3 did better over here, but treatment 1 did better over here. Well, then we can talk about those differences and why there are, and we can explore it a little bit more. Okay, so that was our block design. A block design is just taking these 100 people or however many subjects we have, breaking them up into separate groups beforehand, and then doing a completely randomized design on each group, okay? And again, it doesn't have to be by gender. Like there's an experiment about dogs and you break them up by breed, or you could do, let's say you were doing an experiment on high school students, then you might want to take 9th graders, 10th graders, 11th graders, and 12th graders. Again, you're talking about just breaking up, it's some kind of similar group though. It's like if I was doing an experiment on high schoolers, 9th graders, 10th graders, 11th graders, and 12th graders, that makes sense, right? Because 9th graders might respond differently to something than a 12th grader because of that age difference, okay? 9th graders are similar, they stay in one group. 10th graders are similar, they stay in one group. 11th graders are similar, they stay in one group, and 12th graders are similar, they stay in another group. All right, that was block design, you guys. Good job. Big day of videos, so thank you for your patience.